Before the stars existed, before the cosmos shone, there was absolute darkness. This audiobook invites you on a journey to that forgotten era, a time when the universe was invisible, cold, and silent. We will discover how, after hundreds of millions of years of twilight, the first rays of light emerged, bringing with them the universe we can see today. A story of birth, transformation, and cosmic revelation. Light is more than just the brightness we perceive daily. It is a symbol of life, knowledge, and discovery. However, darkness also plays a crucial role. In ancient times, darkness was the cloak that covered the universe, a mystery that ancient sages sought to unravel. Imagine a night sky filled with twinkling stars. Each one is a reminder of what was before and what is yet to come. In this sense, light and darkness are like two opposing characters in a story unfolding over billions of years. How can we understand the importance of these concepts in the context of the universe? Light allows us to see and explore, while darkness invites us to reflect and seek answers. Throughout history, humanity has used light as a metaphor for understanding and revelation. In many cultures, light represents knowledge, while darkness symbolizes ignorance. But what if these forces are not as opposed as they seem? Modern research shows us that light and darkness coexist in a cosmic dance, a symbiotic relationship that has shaped our universe as we know it. Without darkness, light would have no context. It would be like a painting without a background. In this way, when exploring the origin of the cosmos, one cannot help but ask intriguing questions. How did the first particles of light emerge? What role did they play in the creation of everything we know? As we delve into this exploration, it will be essential to understand that light is not just a physical phenomenon, but also a connection to the deepest parts of our existence. From the first flashes of light that formed in the primitive universe to the stars that shine in the night sky, each flash tells a story. But what does that light tell us about the past and future of our cosmos? Throughout this journey, we will discover how light has allowed humanity to advance in its understanding of the universe. From the ancient philosophers who looked to the sky to contemporary scientists studying cosmic background radiation, the pursuit of light has been a constant in our history. What does light reveal to us about the nature of time and space? And how has it changed our perception of reality? Light also plays a crucial role in the creation of matter itself. Without light, there would be no stars or planets. There would be no life as we know it. Reflecting on this, one might wonder, what importance does light have in the continuity of life? And how has it influenced the evolution of species on our planet? The exploration of light is not limited to the physical. It also extends to the cultural and spiritual. Throughout history, light has symbolized hope, knowledge, and truth. From ancient mythologies to contemporary spiritual traditions, light has been a thread that connects humanity. What does light mean to each of us on a personal level? In this journey, we will also address how modern technology has transformed our relationship with light. From the invention of the light bulb to the sophisticated optical tools we use today, light has been a driver of innovation. But in this sense, a question arises. How does the advancement of technology affect our perception of light and darkness? With each new revelation, light becomes a symbol of our innate curiosity and our desire to understand the universe. As we progress, I invite you to question what you know about light and darkness. What discoveries are waiting to be revealed? What mysteries remain to be unraveled in the vast cosmos? Finally, when considering the relationship between light and darkness, it is essential to remember that ultimately, both concepts are fundamental to our existence. Light could be seen as a beacon in the darkness, guiding us toward a future full of possibilities. So as we navigate this cosmic journey, keep your mind open and your curiosity alive. Light and darkness are waiting to be explored. And together, we will discover what it truly means to shine in a vast and mysterious universe. The universe, as we know it today, began in a unique moment approximately 13,800,000,000 years ago. But what was that primitive universe like? In the first moments after the Big Bang, light was still a distant concept. Imagine a vast emptiness where darkness prevailed in every corner. It was a space where stars, planets, and even the tiniest spark of light simply did not exist. Everything was in a state of chaos and unimaginable density. A hot soup of subatomic particles moving at a dizzying speed. Now, how is it possible that from that immense void and darkness emerged a universe filled with light and life? The key lies in what happened shortly after the Big Bang. In a period we can imagine as the beginning of the cosmic orchestra, as the universe expanded, it slowly cooled down. This drop in temperature was crucial as it allowed the first particles to begin to form. But what kind of particles were these? Protons and electrons, those tiny components that make up atoms. Think of them as the basic bricks of a building. Without these bricks, we couldn't build anything. In this primitive stage, darkness still reigned. But the formation of these particles was the first step toward the creation of what would later become atoms, molecules, and eventually everything we know. But what happened next? Over time, the temperature continued to decrease, and around 380,000 years after the Big Bang, a crucial event occurred known as the era of recombination. At this moment, electrons and protons joined together to form the first atoms of hydrogen and helium. Imagine the universe assembling a puzzle, each piece gradually coming together. When these atoms formed, light began to be released. The drop in temperature allowed light, which had previously been trapped in the chaotic dance of particles, to escape into space. It was as if suddenly the universe turned on a lamp in the midst of darkness. But the story doesn't end here. What happened to the light that emerged from this era? That light, in the form of radiation, has been traveling through the cosmos for billions of years. This phenomenon is known as cosmic background radiation. If we had a powerful enough telescope, we could capture its echoes, a remnant of the early universe, like a distant whisper of its birth. This discovery not only helps us understand the past of the universe, but also reveals the incredible story of how light began to fill the void. As the hydrogen and helium atoms grouped together under the influence of gravity, they began to form the first stars. Imagine a cosmic workshop where these atoms fuse, giving rise to immense spheres of fire. These stars not only illuminate the darkness, but also play a fundamental role in the creation of new elements. But how do they achieve this? Within the stars, a process called stellar nucleosynthesis takes place. It's like a powerful furnace where atoms combine to form heavier elements. This process not only generates light, but also the materials necessary for the creation of planets and eventually for life itself. Stars, then, are true factories of light and matter in the vast workshop of the universe. However, not all stars have a peaceful ending. Some of them, as they exhaust their fuel, explode in a cataclysmic event known as a supernova. This spectacle is not only impressive, but also fundamental for the dispersion of the elements they have created. When a supernova explodes, it releases an immense amount of light into the universe. It's as if an explosion of colors and energy illuminated the cosmos, seeding space with the ingredients necessary for new stars and planets. That bright light we observe in the night sky is the result of millions of years of cosmic history. Galaxies form as gravity groups stars and matter, creating luminous systems that extend over vast distances. But what does this light tell us about the universe? By observing the light from distant galaxies, we can learn about their history, evolution, and place in time and space. Each flash of light is like a love letter from the past, telling us about the adventures those stars experienced. Dark matter, although invisible, plays a crucial role in the formation and luminosity of galaxies. How is it possible that something we cannot see has such an impact? Dark matter acts as an invisible skeleton, shaping the universe and guiding the formation of galactic structures. In its absence, our cosmos would be a very different place, likely much darker. And as we explore these concepts, an intriguing question arises. What is dark energy, and how does it affect the expansion of the universe? This mysterious force seems to be responsible for the acceleration of the cosmos, pushing galaxies away from each other. In this vast sea of light and darkness, dark energy is the hidden engine that shapes our universe. Finally, we cannot forget the importance of light in the formation of planetary systems. The light from stars not only illuminates space, but is also crucial for life. The sunlight that reaches our planet is the engine of vital processes like photosynthesis, which allows plants to grow and in turn feeds the entire chain of life on Earth. Light, then, is not just a physical phenomenon. Throughout human history, it has influenced our culture, art, and science. From the earliest cave paintings to complex laboratory experiments, light has been an inexhaustible source of inspiration and discovery. And in our exploration of space, every beam of light we capture brings us information about the cosmos, helping us unravel the mysteries of the universe. Thus, light and darkness are two sides of the same coin, intertwined in the cosmic dance of the universe. On this journey from primordial darkness to the brilliance of stars and beyond, we understand that light not only illuminates our path, but is also intrinsically linked to the very essence of who we are. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this star odyssey. The first particles in the universe are like the tiny bricks that build everything we see today. After the Big Bang, the universe was in a chaotic state filled with energy and heat. But how did these particles form? The answer to this question reveals a fascinating twist in cosmic history. Imagine a vast playground where the basic elements of matter began to emerge from nothing, like pieces of a puzzle finally fitting together. In this vast ocean of energy, electrons and protons started to appear. Electrons are like tiny sunflowers orbiting around a nucleus, while protons are like the sun at the center, providing stability and shape. But what makes these particles so special? The key lies in their charge. Electrons have a negative charge and protons have a positive charge. This attraction between them is what began to bring them together, forming the first structures of matter. Did you know that, at first, the universe was so hot that atoms couldn't even form? The temperature was so high that any attempt to combine protons and electrons resulted in chaos. But as the universe expanded, it began to cool down. Imagine you are in a hot oven, and little by little you turn it off. As it cools, you can take out your cookies, which were once a messy dough. The same happened with the universe. As it cooled, it allowed particles to start coming together. The union of electrons and protons gave rise to the first hydrogen atoms. These atoms are essential, as they are the building blocks of everything that exists. But what does this mean for the universe? Each hydrogen atom created is like a tiny spark that will later fuel the stars. Without these first particles, we wouldn't have the universe we know today. But it wasn't all easy. The creation of these particles didn't happen overnight. It was a complicated process, full of ups and downs, similar to a puzzle that is assembled with patience and dedication. As electrons and protons formed, the universe was filling with a haze of particles floating in a vast void. This haze is what is known as plasma, a state of matter where particles are not yet fully combined. At this moment, an intriguing question arises. How did we transition from plasma to the matter we can see and touch? The answer lies in the era of recombination, a crucial period when the temperature of the universe decreased enough for electrons and protons to finally come together and form atoms. Imagine that each atom is a small air bubble in a sea of water. As the water cools, the bubbles begin to form and cluster together. The fascinating thing about this process is that once the atoms formed, they began to attract more atoms, creating clouds of gas that would eventually condense into stars. Every star we see in the sky is the result of the union of countless hydrogen atoms, but how do we know this really happened? The answer lies in the light that these stars emit. The light we see today is not just a flash in the sky, but a remnant of the universe's history. Every time we look at the stars, we are looking back in time to those crucial moments when the first particles came together to form atoms and eventually stars. It's as if the universe is telling us its story through the light that travels billions of years to reach our eyes. Furthermore, these first particles did not only form hydrogen atoms. Over time, other elements began to emerge. Fusion inside stars transforms hydrogen into helium and eventually into heavier elements. This process is like a cosmic kitchen where the necessary ingredients are created to form everything we know, from planets to living beings. The importance of these first particles goes beyond the creation of matter. They mark the beginning of a cosmic journey that has shaped our universe. Without them, there would be no stars, no planets, and of course no life as we know it. The connection between these particles and everything around us is a reminder that in the vast universe, every small component plays a crucial role. So the next time you look up at the starry sky, remember that those bright lights are more than just stars. They are the result of a cosmic journey that began with the first particles. A journey that continues to unfold in every corner of the universe. The creation of matter is just the first chapter of a much larger story, a story that invites us to explore, discover, and marvel at the complexity of our cosmos. The era of recombination is a fascinating moment in the history of the universe, a period when darkness began to yield to light. But what exactly happened during this critical stage? Imagine a vast ocean of particles floating in the immensity of space, where the temperature was so high that electrons and protons roamed freely, unable to come together to form atoms. This primitive world was dominated by chaos, but all of that was about to change dramatically. The temperature, after the Big Bang, was like a blazing campfire on a cold night. As the universe expanded, that campfire began to cool. Can you imagine what would happen if a campfire slowly went out? The embers still glow, but the light becomes dim. In this analogy, the universe was cooling, allowing electrons and protons, those fundamental components of matter, to start coming together. At this point, the temperature had dropped low enough for atoms to finally form. The formation of atoms was like the first flash of light in the endless darkness. When electrons joined with protons, the first atoms of hydrogen and helium were created. This process, known as recombination, was as if the universe had sparked a flame in the midst of darkness. Why is this moment so important? Because it was the first step toward the creation of everything we know today. Without those atoms, there would be no stars, planets, or life. Have you ever wondered how light became visible in such a dark universe? This is where the drop in temperature plays a crucial role. As the universe cooled, it allowed light to begin traveling freely. Before this moment, light was absorbed and scattered by the charged particles still floating in space. But now, with atoms formed, light could escape and travel through the cosmos. In a way, this event was like opening a window in a dark room. Suddenly, the light from outside flooded the space. This moment was not only important for light, it also laid the groundwork for the structure of the universe. With the formation of atoms, matter began to clump together. Imagine you have a handful of sand and you let it fall onto a table. The sand particles will group into piles. Something similar happened in the universe. Atoms began to come together, forming clouds of gas that would later give rise to the first stars. But what happened to that light that could now travel freely? That light became an echo of the young universe. During this period, the light emitted during recombination is present today as a trace, like an old photograph of a time that no longer exists. This cosmic background radiation is tangible evidence that there was once a moment when light escaped from darkness, marking the beginning of a new era. As we reflect on this moment, an intriguing question arises. How does recombination affect the way we perceive the universe today? The answer is simple yet profound. Without recombination, we would not have a cosmos filled with bright stars and galaxies. The light we see in the night sky is the result of a process that began billions of years ago, at the instant when atoms started to form and light began to travel. Once this light began to flow, the universe became a vibrant and dynamic place. The first stars, which emerged from the gas clouds, were like beacons in the vast cosmic ocean. These stars not only illuminated space but also created heavier elements through nuclear reactions in their interiors. This is how the light, born from recombination, became the mother of all the matter that surrounds us. As the universe continued to evolve, light became not only a physical phenomenon but also a symbol of hope. In this new cosmic landscape, light represented the future, a future full of possibilities. Who could have imagined that the universe, once shrouded in darkness, would transform into a brilliant spectacle of stars and galaxies? It is fascinating to think that the light we see today in the sky may be a journey through time, a testament to the history of the universe. Each twinkle is a reminder of the moment when darkness was challenged and light began to shine. This story of recombination speaks not only of the physics of the universe, but also of the human quest to understand our place within it. The era of recombination invites us to pause and reflect on the duality of light and darkness. In science, as in life, both concepts are essential. Darkness can be a place of uncertainty, but it is also the context that allows light to shine even more brightly. In this sense, each of us, like the universe, experiences our own eras of darkness and light. As we continue to explore the mysteries of the cosmos, the era of recombination reminds us that even in the darkest moments, light always has the potential to emerge. Every star we see in the sky is a beacon of hope, a reminder that light will always find a way to break through the darkness. Cosmic background radiation is a fascinating phenomenon that connects us to the most primitive moments of the universe. But what is it exactly, and why is it so important? Imagine for a moment that the universe is a large, dark and empty room. In the beginning, there was nothing to see, only a deep silence and total darkness. Then suddenly, there was a burst of light, something like the flashes of a spark in the dimness. That spark is what we know as the Big Bang. But what happened after that explosion? As the universe began to expand, the light generated could not travel very far. Everything was so hot and dense that photons, which are particles of light, could not move freely. It was like trying to run in a room full of smoke. You couldn't see anything and felt trapped. This period of chaos and darkness lasted for about 300,000 years, during which the universe continued to cool slowly. But when did the change occur? The answer comes with the era of recombination. This is the moment when the universe became cool enough for electrons and protons to combine and form hydrogen atoms. At that instant, photons were finally able to break free like a ray of sunlight filtering through an open window. The light that began to travel through space is what we now know as cosmic background radiation. But how did we know this light existed? In 1965, two scientists, Arno Penzias and Robert Wilson, were conducting experiments with an antenna in New Jersey. In their measurements, they found a strange noise that they could not explain, despite their efforts to eliminate that sound. It persisted. Eventually, they realized they were detecting that cosmic background radiation, an echo of the Big Bang. And what does this mean for us? Cosmic background radiation is like a photograph of the universe in its infancy. It provides us with an image of what the cosmos looked like when it was only 300,000 years old. This is crucial, as it helps us understand the evolution of the universe from its earliest moments. It's like having an ancient diary that details the history of a place. Each page offers us clues about what happened in the past. But why is this radiation so uniform? In a vast universe where there are so many galaxies and stars, cosmic background radiation shines uniformly in all directions. This suggests that the universe, in its early moments, was extremely homogeneous. However, small variations in this radiation are like wrinkles on a piece of paper. They tell us about the formation of the first structures, such as stars and galaxies. What do these wrinkles mean for astronomers? These small fluctuations are key to understanding how galaxies formed. Gravity began to attract matter toward denser areas, forming the first structures of the universe. It's like having a small mound of sand on a beach and starting to see how water accumulates on it, creating a larger shape. Thus, astrophysicists can trace the history of the universe through these variations. Moreover, cosmic background radiation not only speaks to us of the past, but also helps us discover the composition of the universe. Through its analysis, scientists have been able to determine that 85% of the matter in the universe is dark, meaning it does not emit light and cannot be seen directly. How is it possible that something so large and mysterious is out there? And we still do not fully understand it. Cosmic background radiation is a testament to the universe in its purest form. It reminds us that despite what we can observe today, there is much more to discover in the vastness of the cosmos. It is a bridge between what we were and what we are, a reminder that light and darkness have been intertwined since the beginning. As we continue to explore, each new discovery adds to our understanding of cosmic history. With each new generation of telescopes and technologies, we are closer to unraveling the secrets that cosmic background radiation holds. Human curiosity drives us to keep seeking answers and to keep asking questions. Just as a child looks at the starry sky, wondering about the constellations, we too look toward the cosmos, seeking to understand our own existence. In conclusion, cosmic background radiation is not just a physical phenomenon, but a fundamental piece of the puzzle of the universe. It connects us to the past, gives us clues about the present, and invites us to reflect on the future. In the end, the light we see today is an echo of those distant moments. A reminder that in the vast darkness of space, there is always a glimmer of hope and discovery. The darkness of the cosmos was, for a long time, the predominant stage. However, at a critical moment in the history of the universe, the first stars began to shine. But how did these stars, which would illuminate the vastness of space, form? The answer lies in the dance of gravity, matter, and energy. Once atoms formed during the era of recombination, an environment conducive to the birth of stars was created. Imagine a vast ocean of hydrogen and helium, where small fluctuations in the density of matter act like bubbles in calm water. These bubbles, driven by gravity, began to attract more and more matter around them. With each grain that joined, the mass increased, and with it, the pressure and temperature in their cores. As the temperature within these gas clouds rose, a fascinating question arises. What happens when the heat becomes extreme? The answer is that a magical process called nuclear fusion begins. In the heart of a newborn star, hydrogen atoms combine to form helium, releasing an immense amount of energy in the form of light and heat. The light emanating from these first stars is a beacon in the darkness of space, marking the beginning of a new era. Did you know that the light from these stars not only illuminates the universe but also creates the foundation of everything we know? Heavier elements such as carbon and oxygen are forged in the hearts of these stars. Without these first generations of stars, we would not have the necessary ingredients for life as we know it. Stars are not just sources of light, they are factories of essential elements. Imagine a workshop where precious metals are melted. In this stellar workshop, nuclear fusion acts as the hammer and anvil, forging new substances from the simplest atoms. When these stars exhaust their fuel, they become supernovae, titanic explosions that scatter these elements into space. Thus, the cycle of creation continues, and the light of a dead star can eventually form new planetary systems. In this vast network of stars, each has its own story to tell. Some larger ones will live only a few million years, while others, smaller ones, may shine for billions of years. How is a star's life determined? The answer lies in its mass. The most massive stars burn their fuel quickly, while the smaller ones do so slowly, like a campfire that stays lit for hours. The light we see today from distant stars is an echo of their past. When we look at the night sky, we are not just observing twinkling lights, but a story unfolding before us. Each bright point is a journey through time, a window into a universe that has evolved over billions of years. However, it is also important to consider that some of these lights have ceased to exist, and what we see is only their memory. The formation of the first stars was a turning point in the history of the cosmos. Without their light, the universe would be a dark and empty place. But what role did these stars play in the structure of the universe we know today? By illuminating the clouds of gas and dust, they began to create the first galaxies, grouping stars into clusters that shone with their own light. The light of a star is not just a visual phenomenon. It is also a means of cosmic communication. Each star emits light at different wavelengths, allowing us to learn about its composition and temperature. By studying this light, astronomers can unravel the secrets of the universe. From star formation to the dynamics of galaxies, the life of a star is a cycle of creation and destruction. As they complete their cycle, they release large amounts of energy and matter into space. This material, in the form of heavy elements, will become new stars and planets, thus perpetuating the cycle of light and darkness. In the end, every star we see in the sky is part of a greater cycle where light transforms and is reborn. The first stars, shining brightly in the dark void, marked the beginning of an era of cosmic splendor. Their light not only illuminated the universe but also laid the foundations for life on Earth. Without these ancient luminaries, existence itself would be unimaginable. Reflecting on the importance of these stars, we realize that their light is a gift that connects us to the past. It reminds us that amidst the darkness there is always a spark of light that can guide us. Thus, the story of the stars is ultimately a story of hope and renewal, a reminder that even in the darkest moments, light can emerge and transform everything around it. In the vast cosmos, stars are the beacons that illuminate the darkness of the universe. But how do these magnificent spheres of light form? The story of star creation is a fascinating journey that begins in the clouds of gas and dust floating in space. In this account, we will delve into the heart of stellar nucleosynthesis, a process that not only brings light to our universe but also creates the elements that make up everything we know. First, it is essential to understand that stars do not appear out of nowhere. Everything begins in a nebula, a vast cloud composed mainly of hydrogen and helium, along with traces of other elements. These nebulae, which can be thousands of times larger than our planet, are the places where the magic of star formation begins to happen. Gravity, that force that keeps us on Earth, starts to do its work, pulling gas and dust toward a single point. As more and more matter gathers, pressure and temperature increase in the core of this cloud. The question that arises is, what happens when the temperature rises high enough? When the center of this accumulation of gas reaches extremely high temperatures, around 15 million degrees Celsius, an incredible process begins: nuclear fusion. This phenomenon is the same that occurs in the center of the Sun and involves the merging of light atomic nuclei to form heavier nuclei. In the case of the first stars, hydrogen nuclei fuse to create helium. But why is this process so important? Nuclear fusion not only releases a colossal amount of energy but also produces light. Think of it as a massive power plant shining in space. This energy radiates outward in the form of light, illuminating the dark universe surrounding it. As the star continues to fuse hydrogen into helium, it becomes what we know as a main sequence star, the longest stage in a star's life. But what happens when a star runs out of fuel? When the hydrogen in the core is depleted, the star begins to change. Nuclear fusion temporarily stops, causing the core to contract under its own gravity. However, this collapse generates an even greater increase in temperature, leading to the initiation of helium fusion into heavier elements such as carbon and oxygen. This cycle of fusion continues, producing more complex elements as the star evolves. At this point, the star expands and becomes a red giant, a cosmic spectacle that can be observed thousands of light years away. A star's life is not eternal, and eventually, its life cycle culminates in a spectacular explosion known as a supernova. This cataclysmic event is not only one of the most powerful explosions in the universe, but is also crucial for the creation of heavy elements like iron and gold. After the explosion, the remnants of the star scatter these elements throughout space, enriching the interstellar medium. But how does this relate to the light we see in the sky? Supernovae emit an immense amount of light during their explosion, which can make them visible even in distant galaxies. Thus, the brightness of these explosions becomes a window that allows us to look back into the universe's past, revealing the history of star and galaxy formation. Every star we see in the sky is the result of billions of years of evolution and the culmination of complex processes that have shaped our cosmos. It is fascinating to think that, in a sense, we are made of stars. The elements that compose our bodies, such as carbon, oxygen, and nitrogen, were created inside these gigantic fusion spheres. Without stars, life as we know it would not exist. Every time we look at the starry sky, we are contemplating the result of atomic fusion in the hearts of these stars, a light that has traveled millions of years to reach us. Stellar nucleosynthesis is a cosmic dance that not only gives life to stars but also provides us with the light and elements necessary for life on Earth. As we continue to explore the universe, it is vital to remember that every twinkle in the sky is a reminder of our connection to the cosmos, a legacy of light that invites us to keep discovering the secrets of the universe. Can you imagine what the sky would be like without those bright stars? A vast ocean of darkness where light plays a crucial role in our existence and understanding of the universe. The light of supernovae is a breathtaking spectacle, a flash in the vast stage of the universe that reveals the secrets of element creation. What exactly is a supernova, and why is it so important for understanding the history of the cosmos? This phenomenon is not just an explosion, it is a cataclysmic event that occurs at the end of the life of a massive star. When a star exhausts its nuclear fuel, the core collapses and in an instant releases an unimaginable amount of energy, shining with a brightness that can outshine an entire galaxy. What is astonishing about supernovae is that they not only illuminate space but also act as cosmic factories. Through nuclear fusion, these explosions generate heavier elements such as iron, gold, and uranium. But how is it possible for a star in its death to contribute to the creation of the elements that make up our world? The answer lies in the incredible physics that takes place within it, where the pressure and temperature are so extreme that they allow atoms to fuse into new elements. Imagine a kitchen where ingredients come together to create an exquisite dish. In the heart of a star, hydrogen and helium are transformed into heavier elements through nuclear reactions, but at the end of its life, when the star explodes, it is as if that dish is scattered throughout the kitchen, distributing the ingredients across the universe. Thus, the elements created in those explosions are dispersed through space, enriching the clouds of gas and dust that will eventually form new stars, planets, and ultimately life itself. The light emitted by a supernova is not only an impressive visual spectacle but also a window into the past. When we observe a supernova, we are seeing light that has traveled through the cosmos for years, even centuries. This means that every time we contemplate a supernova, we are looking at a specific moment in the history of the universe. Isn't it incredible to think that this light has been traveling for so long before reaching our eyes? Astronomers have used supernovae as beacons to measure distances in the universe. Type Ia supernovae, for example, have a nearly uniform brightness. By observing how bright they appear from Earth, scientists can calculate their distance and therefore gain information about the expansion of the universe. This has led to surprising discoveries about the acceleration of that expansion, revealing the presence of a mysterious dark energy that seems to be pushing the universe at an ever-increasing speed. Every time a supernova explodes, it leaves behind a remnant, a kind of fingerprint of its existence. These remnants are clouds of gas and dust that glow with a faint but fascinating light. As they disperse, they become the material from which new stars and planetary systems will form. Thus, the explosion of a star transforms into the beginning of new stellar lives. It is as if the universe has a life cycle in which death is merely the prelude to a new beginning. Supernovae also teach us about the nature of light itself. When a star explodes, the light it emits travels through space, and its spectrum reveals information about the composition of the star and the elements that have formed. Through spectroscopy, scientists can analyze the light and discover which elements are present, helping us understand not only the supernova itself, but also the evolution of stars in general. The light of a supernova is so intense that it can be detected even millions of light years away. This property has made supernovae valuable tools in modern astronomy. By studying the light from these explosions, scientists can better understand the history of the universe, its evolution, and how stars interact with one another. However, there remains an intriguing question: what would happen if supernovae had never existed? The answer is that we would not have the diversity of elements that make up our world. Without these explosions, the universe would be dominated only by the lighter elements. The existence of heavy elements is fundamental for the formation of planets like Earth, and therefore for life as we know it. Supernovae have also left their mark on human culture. In many civilizations, the appearance of a new bright point in the sky has been interpreted as a sign or an omen. These fleeting lights have fascinated amateur and professional astronomers alike, inspiring myths and legends throughout history. The connection between the light of stars and our own lives is undeniable, and supernovae are a reminder that we are part of a dynamic and ever-changing cosmos. As we continue to explore the universe, the light of supernovae will remain a guide, illuminating our path toward understanding. The interplay of light and darkness is a recurring theme in nature, and supernovae are a perfect example of how destruction can give way to creation. In every flash of light, there is a story to tell, and each supernova is a fascinating chapter in the book of the universe. So the next time you look up at the night sky, consider that every star that shines has a story to tell. Some of them have lived glorious lives and have ended in explosions of light that have shaped the cosmos. In that light lies not only the history of the stars, but also the history of matter, of life, and ultimately of ourselves. The light of supernovae is a reminder that in the vastness of the universe, every flash has its meaning. What makes a group of stars turn into a bright and majestic galaxy? To understand this, it is crucial to delve into the fundamental role that gravity plays. Imagine a cosmic dance where the stars are the dancers, and gravity is the music that guides them. Without gravity, the stars would wander alone through the vast space, but thanks to their mutual attraction, they begin to group together, forming increasingly complex structures. Galaxies are not simply random collections of stars. They are like cities of the universe, each with its own history and dynamics. Have you ever wondered how they begin to form? It all starts in the darkness of the cosmos, where dense clouds of gas and dust, known as nebulae, begin to collapse under the force of gravity. Over time, these clouds compact, and within them, stars are born. But what happens after those stars are born? The newly formed stars emit light, and that light spreads across the universe, illuminating the surrounding regions and helping to create new structures. As more and more stars group together, they begin to interact, merge, and in some cases, explode. This process has a cascading effect. The light emitted by the stars not only illuminates space, but also influences the formation of new stars and planetary systems. The spiral arms of a galaxy are like light pathways that connect the stars to each other. But what about the stars that are not on those pathways? Light and gravity work together, creating an environment where stars can live, shine, and eventually die. As stars age, some become supernovae, releasing enormous amounts of energy and materials into space. This explosion is not only spectacular, but also a crucial moment in the creation of new elements. Galaxies like the Milky Way are made up of billions of stars, but they also contain dark matter. This type of matter, which does not emit light and is invisible, plays a vital role in the structure of galaxies. Although we cannot see it, its presence is felt through the gravity it exerts, acting as a cosmic glue that holds stars and other components of the galaxy together. What would happen if dark matter did not exist? Galaxies would be very different, and many of them might not exist at all. Dark matter helps maintain the stability of galaxies, allowing stars and other celestial bodies to group together and shine. Without it, galaxies could collapse and the light we know today could be very scarce. The formation of galaxies is not a static process. Over billions of years, these cosmic structures evolve and change. Some may collide and merge with others, creating even larger galaxies. During these collisions, the light from the stars mixes and transforms, giving rise to new generations of stars and solar systems. This is an endless cycle where light is always at play. Galaxies also tell us stories about the universe. When we observe the light that reaches us from distant galaxies, we are looking back in time. Each flash of light is a window into the past, allowing us to see what galaxies were like billions of years ago. This is like a cosmic archive that speaks to us about the evolution of the universe, helping us better understand our own existence. However, not everything is light and brightness. Darkness also has its role in the formation of galaxies. Low luminosity regions may be where new stars are born, driven by gravity in a tranquil environment. Here, darkness is like a blank canvas where light has yet to be sketched. When we look at the night sky, we can see thousands of points of light that are stars from our own galaxy and others. But did you know that these lights are not all the same? Some are much brighter than others, and this is due to their distance, size, and life stage. The closest galaxies, like Andromeda, may appear brighter and larger due to their proximity, while others, farther away, are just a faint glimmer in the vastness of space. The journey of light from a galaxy to our eyes is an epic journey. From the moment a star emits its light, it can take millions, even billions of years to reach us. Every time we look at the stars, we are seeing the past of the universe, a reminder that light and darkness are intertwined in a cosmic dance that has been occurring since the beginning of time. In summary, galaxies are a testament to the incredible interaction between light and gravity. These structures are not just points of light in the sky, they are the result of a long process of formation and evolution that connects us all. By looking up at the sky, we are part of a vast and beautiful universe where every shining star tells a story of creation, destruction, and rebirth. The light of galaxies not only illuminates the cosmos, but also invites us to reflect on our place within it. The light from distant galaxies is a fascinating phenomenon that invites us to explore the secrets of the universe. What if I told you that the light we see from these galaxies has been traveling through space for millions, even billions of years? Each flash we perceive is a window into the past. But what information does that light really provide us? How can we unravel the history of the cosmos through it? When we observe a distant galaxy, we are not just seeing its light, we are seeing the light it emitted a long time ago. It's as if we are looking at a photograph of an event that happened eons ago. That light speaks to us about the formation of galaxies, the stars that inhabit them, and how they have changed over time. Can you imagine being able to see an event that occurred millions of years ago just because the light from that moment has reached us? Each galaxy is an open book, and its light is the ink that tells its story. Galaxies, those majestic structures floating in the vast ocean of space, are in essence islands of stars. But how do we know how many stars are in them? The answer lies in the brightness of the light they emit. The brighter a galaxy is, the more stars it has within it. So, if you have ever marveled at the sight of a starry sky, think about what lies behind each little flash you see. Each of those points is a star, and its light connects us to the universe. Light also allows us to study the composition of these galaxies by analyzing the spectrum of light that emanates from them. Astronomers can discover what they are made of. Have you ever wondered how scientists know that a galaxy contains hydrogen or helium? It's all in the light. Each chemical element has a unique fingerprint in the light spectrum, like a signature. Thus, from the light that reaches us, we can unravel the secrets of the matter that makes up the universe. Another intriguing aspect of the light from distant galaxies is the phenomenon of redshift. As the universe expands, the light traveling toward us stretches, changing its color. This change is a testament to the movement of galaxies. Isn't it amazing to think that the light from a galaxy that is moving away from us becomes redder, as if it is trying to tell us that it is moving away at high speed? This phenomenon has been key to understanding how the universe is expanding. And what about the oldest galaxies? Some of them are so far away that their light has taken billions of years to reach us. This means we are seeing the universe in its infancy, when the first stars and galaxies were beginning to form. It's a bit like watching a movie that is in the flashback of its plot. Each image we see is a moment in time, a glimpse of what the universe was like in its earliest stages. Light not only tells us stories about the past, but it also helps us understand how the cosmos evolves. By observing the different ages and stages of galaxies, we can learn about the process of formation and development of the universe. It's like unrolling a mural where each layer of paint represents a different period in cosmic history. But not everything is visible light. There are also other types of radiation that reach us from galaxies, such as radio waves, X-rays, and infrared radiation. Each of these types of light offers us a unique perspective on what is happening in the universe. Did you know that some galaxies are so active that they can emit more radiation in the form of X-rays than anything else in the universe? This light shows us regions where new stars are forming, or where there is activity from supermassive black holes. The light from galaxies also plays a crucial role in the search for life beyond our planet. By studying the light they emit, scientists can look for signs of elements that are essential for life, such as oxygen and carbon. Imagine that the light we observe not only reveals the history of the universe, but could also be the key to finding life on other worlds. Each star, each galaxy could be a new home waiting to be discovered. Modern technology has expanded our ability to study the light from galaxies. With powerful telescopes and advanced technology, astronomers can detect galaxies that were previously invisible. This has opened a new era in astronomy, where more and more galaxies are added to our knowledge. Thus, the light that was once lost in the vastness of space now becomes valuable information. And let's not forget that the light from these distant galaxies also connects us all. Every time we look at the starry sky, we are looking back in time and remembering that we are part of a vast universe. Light unites us across time and space, and each spark we see is a reminder that we are made of the same particles as those galaxies. So the next time you observe a distant galaxy, remember that you are not just seeing light. You are contemplating the history of the universe, the dance of the stars, and the promise of discoveries yet to come. Light, in its essence, is the thread that weaves the great tapestry of the cosmos, and each flash invites us to keep exploring and discovering what lies beyond. Dark matter is one of the great mysteries of the universe. Although we cannot see it, we know it is there. But how can we be so sure of its existence if it does not emit light or interact with matter in the way we are accustomed to understanding? One way to comprehend it is to think of a large puzzle with many missing pieces. When we look at the night sky, we see bright stars, but we also notice spaces where it seems there is nothing. However, the gravity of those stars and galaxies indicates that there is something else we cannot see. The influence of dark matter is felt in every corner of the cosmos. Have you ever wondered why galaxies rotate at the speed they do? If we only consider visible matter, the stars and gas we can observe, these galaxies should be disintegrating as if they were a vinyl record spinning too fast. But they do not. Why? The answer lies in dark matter, which acts like an invisible glue, holding galaxies together with its gravitational force. Imagine you are at an amusement park where roller coasters glide through the air. If visible matter were just the roller coasters, dark matter would be the rail system that keeps them in place. Without those rails, the roller coasters could not operate safely and stably. This is how dark matter allows galaxies to stay together and continue spinning in harmony. But where does this dark matter come from? That is a question scientists have been trying to answer for decades. Some believe it could be made up of exotic particles that we have not yet discovered, while others suggest it might be a form of matter that simply does not interact with light. It's like having a friend who is always at the party, but you cannot see them. You can only feel their presence by how they affect others. Dark matter also plays a crucial role in the formation of large-scale structures in the universe. When small fluctuations in space turn into large groupings of matter, dark matter acts as scaffolding, helping to shape galaxies and galaxy clusters. Without it, the universe would be a very different place. One where galaxies could not form the brilliant displays we know today. As we observe the cosmos, we notice that galaxies are not just randomly distributed. There is a pattern, a network of filaments and voids that resembles a spider web. This network is the result of the influence of dark matter, which acts as an invisible guide. Imagine you are looking at a spider web. The spider may not be visible, but its work of weaving the web is what gives it shape and structure. The mystery of dark matter also leads us to reflect on the very nature of reality. If we can feel its influence but cannot see its form, what other things might be around us that we are unable to perceive? This opens up a range of possibilities about how we understand the universe and our place in it. One of the most fascinating discoveries about dark matter is its ability to group galaxies. Computer simulations have shown that, in most cases, galaxies in clusters are surrounded by a large amount of dark matter that keeps them together. Like an invisible magnet, it's like a group of friends gathering at a party, and even though you cannot see the music that keeps them dancing, you know it is there because you can feel the energy in the air. The search for dark matter has led to the creation of experiments and telescopes around the world. Scientists are trying to detect those mysterious particles, searching in the darkest places of the universe and using cutting-edge technology to try to capture their signals. It's a bit like being a detective in a mystery movie where every clue can bring us closer to solving the puzzle. As we advance in our understanding of dark matter, we also face the question of how it relates to light. Although dark matter does not emit light, its presence affects how light travels through space. This phenomenon, known as gravitational lensing, occurs when the light from distant objects bends around a massive object, as if passing through a lens. This allows us to see galaxies that would otherwise be hidden from our view. Dark matter is not only an essential component of the cosmos, but also a reminder of how little we truly understand about the universe. Each discovery about its nature brings us closer to unveiling the secrets of the cosmos, but it also reminds us that there is still much more to learn. This ongoing quest for knowledge is what drives scientists to continue exploring the cosmos and questioning what we think we know. Ultimately, dark matter shows us that the universe is full of surprises and mysteries. Just as light illuminates our world, the search for what lies beyond the visible leads us to delve into the depths of the cosmos. Dark matter is a reminder that, although we cannot see everything around us, its influence is powerful and omnipresent, and it remains one of the greatest enigmas of modern astronomy. The next time you look up at the starry sky, remember that there is much more than meets the eye, and that the universe continues to reveal its secrets little by little. How is it possible that the universe is expanding at an accelerating rate? This is one of the great mysteries posed by modern cosmology. The answer to this intriguing question lies in a concept that many of us have heard of, but few fully understand: dark energy. But what exactly is dark energy, and how does it influence our universe? To understand dark energy, we first need to think about how the universe behaves. Imagine that the universe is like a large elastic band. At first, when it was created, this band was very compressed, and as it expanded, it began to stretch. Normally, one would expect that as it expands, the forces of gravity would pull nearby galaxies toward each other, slowing down this expansion. However, something curious is happening. The expansion is accelerating. What is causing this? This is where dark energy comes in. This mysterious force, believed to make up about 70% of the universe, acts like a kind of push. Instead of being an attractive force like gravity, dark energy seems to have a repulsive effect. Imagine you are inflating a balloon. As air enters the balloon, it expands. Similarly, dark energy is inflating space itself, causing galaxies to move away from each other at an ever-increasing rate. Now, how do we know that dark energy exists? One of the most important clues came from the observation of supernovae. These stellar explosions are so bright that they can be seen from millions of light years away. When astronomers observed supernovae in distant galaxies, they noticed that they were dimmer than expected. This meant they were farther away than thought, indicating that the universe is expanding faster than it should if we only considered gravity. This discovery was a real wake-up call. Could there be a force at play that we have not seen or understood? Dark energy became one of the most fascinating questions in cosmology, but what role does it play in the light we see in the universe? It is interesting to think that light itself is also subject to this expansion of the cosmos. When we observe distant galaxies, their light has traveled through space for millions of years. Due to the expansion of the universe, this light stretches, a phenomenon known as redshift. Think of a train whistle as it moves away. As it recedes, the sound becomes lower. Similarly, the light from distant galaxies shifts to longer wavelengths, becoming redder. The farther away a galaxy is, the faster it is receding, and the redder its light becomes. What does this mean for our understanding of the universe? It tells us that not only is space expanding, but it also provides us with a window into the past. Every flash of light we receive from distant galaxies is an echo of their history. The farther we look, the further back in time we are observing. Dark energy, therefore, is not only affecting the expansion of the universe, but also helping us understand how it has evolved over billions of years. However, dark energy remains an enigma. Scientists have proposed many theories, but there is still no clear consensus on its nature. Some theories suggest it could be a property of space itself, a kind of energy vacuum that has always been present. Other theories propose that it might be related to quantum gravity, a field of study that attempts to unite general relativity with quantum mechanics. The question we all ask is, what will happen to the universe in the future? If dark energy continues to dominate, it could lead to a scenario known as the Big Rip. In this scenario, the acceleration of expansion could be so extreme that galaxies, stars, and even atoms would be torn apart. On the other hand, if gravity were to dominate, we could face a big crunch where the universe contracts. These dystopian fates make us reflect on the fragility and mystery of our cosmos. Meanwhile, research continues. Each new telescope and each new observation brings us a little closer to unraveling the mystery of dark energy. As we gather more data, we can refine our theories and approach a deeper understanding of how the universe works. In this journey toward discovery, it is important to remember that the search for truth is as much about the process as it is about the results. Dark energy, though enigmatic, reminds us that there is much we still do not understand. It invites us to question, to explore, and to marvel at the vast universe in which we live. Light and darkness, as well as energy and matter, play a crucial role in the history of our cosmos. Dark energy, with its ability to expand the universe, is a testament to the unknown that still awaits us. As we continue to probe the secrets of the universe, let us remember that every answer we find may generate new questions. And that is what makes science and exploration so exciting. The formation of planetary systems is a fascinating phenomenon that connects us with the very essence of life. What role does light play in this process? To understand it, it is essential to remember that everything begins in the vast clouds of gas and dust floating in space. These clouds, known as nebulae, are the birthplaces of stars and eventually planets. But how does that cloud of matter turn into a planetary system? When a part of the nebula collapses under its own gravity, it begins to spin and concentrate into a core. This is the moment when the magic begins. As the core heats up, conditions become favorable for nuclear fusion to start. It is in this process that stellar light is born. But what happens to the remaining material surrounding this new star? The light generated by the young star acts as a beacon in the darkness. It heats the surrounding material and creates an environment where atoms can join together to form larger particles. At this point, light not only illuminates but also becomes a catalyst for creation. Planets begin to form from the remnants of gas and dust that orbit around the star, like dancers on a cosmic stage. But what makes some of these bodies become planets while others become asteroids or comets? The answer lies in distance. The temperature and light from the star influence the composition of the planets that form. The closer planets, where light and heat are more intense, tend to be rocky and solid. In contrast, those that are farther away may retain gases and ice, resulting in gas giants. This delicate balance between light and distance determines the nature of each planet in the system. Isn't it amazing to think that the light from a star can shape entire worlds? But the story doesn't end there. Light also influences the formation of atmospheres on these planets. As planets develop, sunlight can interact with the gases surrounding them, creating atmospheres rich in oxygen, nitrogen, and other vital elements. Without this light, many planets would not have the necessary conditions to host life. So is light the key to existence itself? Looking at our own solar system, we see how the light of the sun has shaped Earth. Sunlight not only provides us with heat and energy, but also allows water to exist in liquid form, an essential condition for life. Without sunlight, our planet would be a frozen, desolate world, an inhospitable place for any form of life. It's almost as if light is weaving the very thread of life itself. But what are the limits of light's influence on planetary systems? There are planets at the edges of the solar system, far from their parent star, where light is dim and cold. These worlds, though inhospitable, teach us that life can arise under diverse conditions. Light may not always be bright, but its presence remains fundamental. Over the decades, scientists have explored space in search of planetary systems similar to ours. With advancements in technology, they have managed to identify thousands of exoplanets. Some of these worlds orbit stars that emit light in ways we cannot imagine. The diversity of light in the universe translates into a variety of possibilities for the formation of life. Could living beings exist on worlds where light is completely different from ours? The search for life on other planets is closely linked to light. Astronomers study the light coming from other solar systems to understand their composition and potentially their habitability. Signals from light can reveal the presence of water, oxygen, and other elements essential for life. Thus, light not only illuminates but also serves as a message in a bottle cast across the vast ocean of the cosmos. Light also plays a crucial role in the evolution of life on Earth itself. As planetary systems form and evolve, light can affect how species adapt to their environment. Photosynthesis, for example, is a process that converts sunlight into chemical energy, allowing plants to grow and in turn nourish the entire food chain. Without light, the cycle of life as we know it would not exist. The interconnectedness between light and the formation of planetary systems invites us to reflect on our own place in the universe. Light is more than just a physical phenomenon. It is a symbol of life and transformation. It reminds us that in the vastness of the cosmos, every shining star has the potential to give life to entire worlds. In the end, the story of light and the formation of planetary systems is a reminder of the beauty and complexity of the universe. It invites us to look up at the stars and wonder about the secrets the cosmos still holds. In every flicker of light, there is a story waiting to be told, and each new discovery brings us one step closer to understanding our connection to the universe. Sunlight is much more than just a ray that brightens our day. Its importance transcends the physical realm and delves into the very heart of life on Earth. But have you ever wondered how sunlight becomes the engine of life? The answer lies in a fascinating process called photosynthesis. This phenomenon is like a magical transformation. Plants, those green beings that surround us, are true alchemists. Through their leaves, they capture sunlight and convert it into energy. But how do they do it? They use a pigment called chlorophyll, which is responsible for giving them their characteristic green color. This pigment acts as a receptor, absorbing sunlight and harnessing its energy. Imagine that each leaf of a plant is a small solar panel. When light hits it, a chemical reaction occurs that allows plants to take carbon dioxide from the air and water from the soil and convert them into glucose. This process not only provides them with food, but also releases oxygen, a vital gas for us. Without photosynthesis, life on Earth as we know it would not exist. Isn't it amazing to think that plants are our allies in oxygen production? But what would happen if we didn't have sunlight? The answer is clear. The planet would plunge into darkness, and life as we know it would extinguish. Sunlight is the beginning of the food chain. From the tiny organisms floating in the oceans to the large mammals that walk the earth. We all depend on this vital energy. Thus, light becomes the thread that connects all living beings in a delicate balance. The impact of sunlight goes beyond photosynthesis. It also influences the life cycles of plants and animals. For example, many plants bloom in response to the amount of light they receive. This phenomenon is called photoperiodism. Have you ever noticed how flowers open during the day and close at night? This behavior is an adaptation to maximize light capture and, therefore, their growth. Animals, for their part, also respond to light in surprising ways. Some species migrate according to the position of the sun, while others regulate their daily activity based on light. Sunlight even affects our emotions and mood. Who hasn't felt more cheerful on a sunny day? Sunlight has a positive effect on the production of serotonin, the happiness hormone. The relationship between light and life does not stop on Earth. In the vast universe, the search for life on other planets often begins with the search for light. Scientists study stars and their planetary systems to determine if they could harbor life. The presence of water and sunlight is fundamental for the development of organisms similar to those we know. Therefore, light has become a key indicator in astrobiology. In everyday life, light plays multiple roles, from lighting our homes to its use in modern technology such as the screens of our devices. Light is essential for communication and connection. Can you imagine a world without electric light? Darkness would deprive us of the ability to explore, learn, and share. Moreover, light has influenced human culture throughout history. From the creation of works of art to literature, light has been a source of inspiration. Artists have used light to bring their works to life, while poets have found in it a symbol of hope and renewal. In this sense, light becomes a reflection of our emotions and aspirations. The traditions and beliefs of various cultures have also been shaped by light. In many religions, light symbolizes the divine and the sacred. Festivals that celebrate light, such as Christmas or Diwali, are moments when communities come together to celebrate life, hope, and renewal. In recent times, the importance of light has become even more evident. In a world where technologies are advancing rapidly, light plays a crucial role in the development of new energy sources. Solar energy, for example, is becoming a fundamental pillar in the search for sustainable alternatives. Harnessing sunlight to generate clean energy is one of the most promising solutions to face environmental challenges. Reflecting on the role of light in our lives leads us to understand that it is not just a physical phenomenon, but also an essential element for the existence and development of life. Light connects us all, from the smallest organism to human beings. It reminds us that no matter how dark a situation may seem, there is always a source of light that guides us and gives us hope. As we continue to explore the vast universe and its mysteries, light will remain our traveling companion. It will allow us to discover new worlds, understand our place in the cosmos, and appreciate the beauty of life in all its forms. So the next time you see a ray of sunlight, remember that this little glimmer is much more than light. It is the beginning of life itself. Light has been a source of inspiration and a symbol of knowledge throughout human history. From the earliest civilizations, people have looked to the sky and marveled at the brightness of the stars, associating their light with divinities and extraordinary phenomena. What does light really mean in our culture? How has it influenced our art, our beliefs, and our understanding of the world? Light has been represented in literature as a beacon of hope. Consider the numerous stories that center around the idea of light guiding heroes on their journey. In ancient times, light represented truth, while darkness symbolized ignorance. Thus, the quest for light became a metaphor for the pursuit of knowledge. But why is this metaphor so powerful? Light, being visible and tangible, becomes a perfect representation of what we wish to achieve: clarity, understanding, and truth. Art has also found in light a primary means of expression. Painters like Caravaggio and Rembrandt have used contrasts of light and shadow to create drama and emotion in their works. How does light manage to transform a simple scene into something profoundly moving? Light can evoke feelings, convey atmospheres, and ultimately connect the viewer with the artwork on a deeper level. When we observe a masterfully lit painting, we can feel the energy of the light vibrating through the canvas, giving us an experience that goes beyond the visual. Light has not only impacted art but also religion. In many spiritual traditions, light is seen as a symbol of divinity. The light of candles in a ceremony, the glow of the sun at dawn, these are all considered sacred. How has this connection between light and spirituality endured through the centuries? Perhaps it is because light has the ability to unite people, providing them with a sense of hope and community in times of darkness. Science, for its part, has also had its own relationship with light. From the discovery of electricity to the invention of photography, light has been a driving force of innovation. How has it changed our daily lives? Consider how artificial light has transformed the way we live, work, and interact. Thanks to the invention of the light bulb, our days are extended and our nights illuminated, allowing us to explore and create in moments that were once filled with darkness. Today, light remains a fascinating topic in science and technology. Who hasn't marveled at advancements in screen technology that allow us to display vibrant images and intense colors? Light is the medium through which we experience digital reality. Every time we watch a video, play a video game, or read on a screen, we rely on light to access those virtual worlds. Moreover, light plays a crucial role in education. The way we learn and understand complex concepts is often facilitated by the use of graphics, diagrams, and visual presentations. How could we imagine a classroom without the light that illuminates the blackboard or the projection of images? Light allows us to see and comprehend, becoming an ally in our quest for knowledge. Music, another form of art, has also found its way through light. Concerts and festivals are often an explosion of lights accompanying the music, creating a multi-sensory experience. The combination of light and sound can change our mood, making us feel joy, nostalgia, or even euphoria. How can this synergy between light and sound affect our emotions so profoundly? The relationship of light with time is also fascinating. From ancient sundials to modern atomic technologies, we have used light to measure the passage of time. What does this say about our perception of the passing days and seasons? Light, by marking the rhythm of our lives, becomes a constant reminder of the fleeting nature of time. And let's not forget light in photography. Capturing moments through the lens of a camera is, in essence, a play of lights. Each photograph tells a story, and light plays a crucial role in how that story is told. How can an image evoke such vivid memories and emotions? It all comes down to how light is captured and manipulated. Finally, light invites us to reflect. It reminds us that although darkness can be overwhelming at times, there is always a way to illuminate our path. Light becomes a symbol of the hope we carry within, a reminder that no matter how difficult the road may be, there will always be a ray of light guiding us forward. So, as we contemplate light and its influence on our culture, it is impossible not to feel a deep connection to it. Light not only illuminates our surroundings, but also enlightens our minds and hearts, giving us the clarity needed to navigate through life. In this constant journey between light and darkness, we find not only the essence of our universe, but also the essence of our humanity. The exploration of space is one of humanity's greatest achievements. But how has it been possible to undertake this monumental adventure? The answer lies in light, from the first telescopes to the powerful probes that today traverse the far reaches of the solar system. Light has been our beacon in the darkness of the cosmos. Without it, our visions of the universe would be mere shadows. When we look at the night sky, every star we see is a testament to light traveling through space. But did you know that the light we observe from those stars may have begun its journey thousands or even millions of years ago? This means that when we look at the sky, we are looking back in time. Each flash of light is an echo of a distant time and place. In this sense, light becomes a time machine, allowing us to observe the history of the universe. But what about the planets and moons that orbit around those stars? Light also plays a crucial role in our understanding of these celestial bodies. By analyzing the light reflected by the planets, astronomers can determine their composition, temperature, and even their atmosphere. Each color in the light spectrum reveals a secret about the world that emits it. Thus, light not only illuminates the path, but also tells us stories. Light has been essential in the search for life beyond our planet. Imagine the excitement of scientists discovering exoplanets, worlds that orbit other stars. The light from these planets, when filtered through their atmospheres, offers clues about their potential to harbor life. Each analysis of light is an opportunity to discover if there are other places in the universe where life might exist. And it's not just about searching for life. Light also helps us understand the processes that occur in space. For example, supernova explosions, which are some of the most powerful explosions in the universe, release an immense amount of light. Studying this light allows us to learn about the life and death of stars, as well as the creation of essential elements that form everything we know, including ourselves. Space exploration is not limited to observation. Light has been fundamental to the development of technologies that allow us to travel further. Lasers, for example, are used in navigation and communication systems aboard spacecraft. Without these advancements, our interplanetary missions would have been much more difficult, if not impossible. But what about the challenges? Light also presents obstacles. For instance, the light from stars can be distorted by the Earth's atmosphere, making precise observation from the ground difficult. This is where space telescopes come into play, positioned beyond the atmosphere to observe the universe with astonishing clarity. Thanks to these instruments, we have been able to capture stunning images of distant galaxies and cosmic phenomena. Light also plays an essential role in the discovery of new phenomena. Quasars, for example, are extremely bright sources of light found at the center of some galaxies. Their intense light provides us with information about the matter surrounding them and how they behave under extreme conditions. Each flash from a quasar is a window into the mysteries of the universe. As we explore beyond our solar system, light becomes our main ally. It not only helps us observe, but also guides us in the development of new technologies, from propulsion engines that use optical principles to communication systems that transmit information through lasers. Light is at the heart of space innovation. But what does the future hold for us? With advances in observational technology, such as more powerful telescopes and more sophisticated satellites, our ability to explore the cosmos will expand exponentially. Light, which has been our guide so far, will continue to illuminate the path toward new discoveries. Imagine the wonders that still await us in the vastness of space. The story of light in space exploration is one of wonder and discovery. Every beam of light we capture is a reminder of how far we have come and what we still have to learn. Light not only connects us to the universe, but also unites us as a species. It drives us to keep seeking answers and to never stop exploring. So the next time you look up at the starry sky, remember that each bright point is more than just light. It is a symbol of our curiosity and our relentless pursuit to understand the unknown. Light is undoubtedly one of the most powerful forces in our exploration of the cosmos. Light and modern technology are two forces that have transformed our existence in ways we often cannot even imagine. From the moment we wake up until we go to bed, light, in its various forms, plays a crucial role in our lives. But how has light influenced the technological advancements we take for granted today? Join me in unraveling this fascinating link. First, let's think about a simple everyday object, the mobile phone. This device, which seems to be an extension of our hands, relies on light to function. Phone screens use backlighting technology, which allows pixels to emit light and create vibrant images. However, that's not all. The way we capture images with our cameras is also based on light. camera sensors convert light into electrical signals, enabling us to capture moments and share experiences with the world. So, what role does light play in the visual communication we value so much? The answer lies in the very nature of light. Through fiber optics, light becomes a medium for transmitting information at astonishing speeds. Imagine sending a text message to a friend living on the other side of the world. What you may not know is that your message travels through fiber optic cables, where light is used to transmit data in the form of light pulses. This allows information to flow seamlessly, making our communications instantaneous. Isn't it amazing to think that something as simple as sending a message is the result of complex interactions of light? Even in the field of medicine, light has revolutionized the way we diagnose and treat diseases. Imagine an operating room illuminated with bright, precise light. That light not only allows surgeons to see what they are doing, but is also crucial in procedures like endoscopy. Here, light is used to illuminate the inside of the human body, facilitating the detection of diseases. However, light also has therapeutic properties. Phototherapy, for example, uses specific wavelengths of light to treat skin conditions like psoriasis. Thus, light becomes an ally in the fight for our health. Another field where light has had a significant impact is scientific research. Microscopes, which are fundamental tools in laboratories around the world, use light to magnify tiny objects and reveal details invisible to the naked eye. Without the ability to manipulate and direct light, we would not have access to such a small and fascinating world. What discoveries would escape us if we could not see what lies beyond our perception? Moreover, the use of light is not limited to research. It has also become an essential tool in education. Light projections and visual presentations are common methods for conveying information. Modern classrooms are equipped with projectors that use light to display images and videos, making learning more interactive and engaging. Wouldn't it be difficult to imagine a class without the help of light to illustrate complex concepts? Innovations in lighting have also changed our environment. LED bulbs, for example, are a testament to how technology has evolved to make efficient use of light. These bulbs not only consume less energy, but also have a longer lifespan, representing a significant advancement in sustainability. By choosing the right light, we not only illuminate our spaces, but also contribute to a healthier planet. Have you ever wondered how much energy you could save simply by changing the way you light your home? Light also plays a key role in space exploration. Telescopes, both ground-based and space-based, rely on light to observe celestial bodies and decipher the secrets of the universe. When we look at the stars, we are actually seeing light that has traveled thousands of years to reach us. Thanks to technology that harnesses light, we can study distant galaxies and better understand our own existence. What mysteries of the cosmos would be revealed if we could see even further? Furthermore, light has led to the creation of smart devices that respond to our environment, from bulbs that turn on when motion is detected to security systems that use light to alert us about intruders. Light has been integrated into our daily lives in ways that enhance our comfort and safety. Who could imagine a home without technology that uses light to make our lives easier? In the realm of entertainment, light is fundamental in creating immersive experiences. Movies and video games use light effects to generate atmospheres, emotions, and visual narratives. The way light is manipulated in cinematography can make a simple moment feel epic or intimate. Have you ever considered how light can change the perception of a story? Finally, light has also influenced art. Painters and artists have explored the properties of light for centuries, using shadows and reflections to bring their works to life. From impressionists to contemporary artists, light has been a key element in creating visual beauty. How does light affect our appreciation of art and aesthetics? As we move toward the future, the relationship between light and technology will continue to evolve. New innovations in lighting, communications, and scientific exploration are on the horizon, promising changes we may not yet be able to imagine. What new wonders will light bring us in the coming years? Light and modern technology are more than separate concepts. They are two intertwined elements that define our experience of the world. Through light, we have created a bridge between science, communication, and art, thus illuminating our path toward the future. Reflecting on this link helps us appreciate not only the technology we use, but also the light that surrounds us and its fundamental role in our lives. What if I told you that there are places in the universe where light behaves in truly strange ways? In the depths of the cosmos, there are optical phenomena that challenge our understanding and resemble the best magic tricks. These mysteries invite us to explore what happens in those distant corners where gravity is so intense that not even light can escape. One of these phenomena is black holes. Imagine a place in space where gravity is so strong that everything that approaches it gets trapped, as if it were inside a giant vacuum cleaner. But how is it possible that light, which travels at the fastest speed known, cannot escape? This is because, as it approaches a black hole, light encounters a gravitational field so powerful that it curves and folds over itself, creating what we know as the event horizon. Beyond this limit, light simply cannot return. It's as if there were a great invisible wall separating the observable from the unknown. Now let's talk about quasars. Imagine a star so distant that its light has been traveling for billions of years just to reach your eyes. But this is not just any star. Quasars are the cores of active galaxies that emit an overwhelming amount of light, brighter than all the stars in their galaxy combined. What makes them so special? The answer lies in the matter swirling around them, which heats up to extreme temperatures as it is absorbed by a supermassive black hole. This process generates a dazzling light that we can observe from Earth, even if it is billions of light years away. What about gravitational lenses? This phenomenon occurs when the light from a distant object passes near a massive object, such as a galaxy or a cluster of galaxies. The gravity of the massive object acts like a lens, bending the light and magnifying the image of the distant object. It's like looking through a magnifying glass, where the object becomes larger and easier to observe. This not only helps us see objects that would otherwise be invisible, but also provides valuable information about the distribution of matter in the universe. Light can also be deceptive in its path. There are regions in space where light is trapped and then released, creating an effect that seems to defy all the laws of physics. For example, in certain areas of galaxies, light can be absorbed by cosmic dust and then re-emitted at different wavelengths. This is similar to how a sponge can absorb water and then release it slowly. This process gives us clues about the composition and temperature of the stars and gas surrounding them. The interaction between light and empty space can also generate fascinating phenomena. Light can be stretched and shifted by the expansion of the universe, a phenomenon known as redshift. Imagine you are listening to an ambulance siren moving away. As it moves away, the sound becomes lower in pitch. Light does something similar. As the universe expands, the light from distant galaxies shifts toward the red. This shift helps us understand how the universe is expanding and offers a glimpse into the past. But what about the stars that are about to die? When a massive star explodes in a supernova, it generates an immense amount of light and energy, shining brightly for a short period of time. This explosion not only illuminates the surrounding space, but is also responsible for the creation of many of the elements that make up our universe. The light from these explosions can be seen at unimaginable distances and provides us with information about the life and death of stars. In the journey of light through the universe, there are moments when it encounters magnetic fields. These fields can affect the trajectory of light, creating patterns of polarization. This phenomenon can be compared to how a polarizing filter can change the way we see an object in our daily lives. Scientists use this information to better understand the structure of the cosmos and the processes occurring within it. Sometimes light can be captured in its purest form. Pulsars, for example, are rapidly spinning neutron stars that emit beams of light at regular intervals. It's like having a lighthouse in space, emitting flashes of light that can be detected at enormous distances. These pulses of light are not only fascinating for their regularity, but also provide us with information about matter in extreme conditions. Optical phenomena in the universe are not only visually stunning but also tell us stories about the history of the cosmos. Every flash of light, every change in its path is a signal of the events that have occurred since the Big Bang. Light is the messenger of the universe, carrying information about its past, present, and possibly its future. Understanding light in these contexts helps us connect with the very nature of the cosmos. It reminds us that, although the universe may seem dark and confusing, there is an inherent beauty in its complexity. Light, in all its forms, is a thread that ties our experience here on Earth to the vast and mysterious universe that surrounds us. So the next time you look up at the starry sky, remember that each point of light has a story to tell. Each star, each galaxy, each optical phenomenon is a testament to the cosmic dance between light and darkness. A reminder that, in the vast universe, light will always find a way to shine. In the vast universe, light is not just a physical phenomenon. It is a thread that connects the history of the cosmos with our present. But what path has this light taken to reach us? As we explore the future of light in the universe, it is fascinating to reflect on its evolution and the role it will play in the mystery that surrounds us. Light has witnessed extraordinary cosmic events, from the explosion of the Big Bang to the formation of complex structures like galaxies and planetary systems. But as the universe expands, the crucial question is, will light eventually extinguish? Stars, those natural factories of light, have a life cycle. Some shine brightly for billions of years, while others burn out quickly in supernova explosions. What will happen when the stars run out? A future where darkness prevails may seem bleak, but it could also be a new beginning for the universe. In this scenario, the idea of eternal light emerges. Is it possible that, even when the stars go out, light will continue to flow in other ways? The existence of black holes poses an intriguing paradox. They absorb light, but they could also be gateways to unknown dimensions. What secrets might they reveal about the nature of light and space-time? Perhaps in a distant universe, light will find new ways to manifest, challenging our current understanding. The expansion of the universe, driven by mysterious dark energy, also raises intriguing questions about light. How will light behave as the universe continues to expand? As galaxies move away, their light shifts toward the red, a phenomenon that tells us about the speed at which they are receding. Could this mean that in the future some galaxies will become invisible to us? What implications would this have for our understanding of cosmic history? Light can also be a messenger from the future. Through technology, we have begun to explore space and capture light signals from distant galaxies. But what will happen when humanity reaches even farther limits? Will we at some point be able to send light across the cosmos to communicate with civilizations inhabiting distant worlds? The possibility that there are life forms interpreting light in ways different from ours opens up an ocean of possibilities. The nature of light, its duality as both wave and particle, leads us to consider how it might evolve in the future. Could there be forms of light that we have yet to discover? Perhaps there are frequencies of light that are undetectable to our senses but could be key to understanding the universe. What secrets might light hold that we have yet to unravel? The search for new sources of light could also be crucial for the future of life. In a universe that is cooling and expanding, finding energy and light will be vital for the survival of species. Photosynthesis, which has sustained life on Earth, may have analogies in other worlds where light from different stars enables life in ways we have never imagined. Future explorations of our solar system and beyond will also lead us to rediscover light. Imagine missions studying planets and moons in search of life, using light as their guide. What discoveries await us in those worlds? Light will be our compass, illuminating unknown paths and revealing the diversity of life. However, the future of light is not only tied to the physical, it also has philosophical implications. As the universe expands and transforms, how will it affect our perception of existence and consciousness? Light has long been a symbol of knowledge and truth. How will this be redefined as we move toward an uncertain future? Light, in its purest essence, can be seen as a link between the past, present, and future. Its journey through the cosmos, filled with ups and downs and mysteries, invites us to reflect on our own place in the vast panorama of the universe. What legacy will we leave in this eternal dance between light and darkness? The answer to this question may be as bright as light itself. Thus, as we contemplate the future of light in the universe, it is essential to remember that every glimmer we see in the sky is a reminder of our connection to the cosmos. Light, in all its forms, invites us to keep exploring, to keep questioning, and above all, to keep dreaming. In the search for answers, light will always be our beacon in the darkness, guiding us toward the unknown. What if I told you that light not only illuminates our path, but is also the key to understanding the vast universe around us? In every corner of the cosmos, light plays a fundamental role, acting as a beacon that guides us through the history of the creation and evolution of galaxies, stars, and of course our own existence. But why is light so important? The answer to this question not only reveals fascinating facts about the universe, but also invites us to reflect on our connection to it. Since the dawn of time, light has been a symbol of life and knowledge. In ancient times, civilizations worshipped the sun, recognized its power, and revered it as a source of energy and life. Today, in our quest for answers about the universe, that same light becomes our main ally. Every twinkle we see in the night sky is a testament to the past, an echo of events that occurred thousands or even millions of years ago. Isn't it amazing to think that by observing the stars, we are actually looking back in time? Light has the ability to tell stories. Every photon traveling through space carries information about its place of origin, allowing us to learn about the composition of stars, the temperature of planets, and even the presence of chemical elements in distant worlds. How is it possible that a simple ray of light can reveal so much? The answer lies in the way it interacts with matter. When light touches an object, it is reflected, absorbed, or scattered, and each of these interactions provides us with clues about what lies beyond. Through telescopes, we have been able to gather a vast amount of information about the galaxies that populate our universe. Every image we capture is like a page from an ancient book, full of secrets waiting to be discovered. Can you imagine what we could learn if we had the ability to read each of those pages? Light not only helps us understand the past, but also allows us to explore the future. The expansion of the universe, driven by mysterious dark energy, is in constant motion. What will this expansion bring us in the coming millions of years? Light also connects us in more personal ways. On our planet, it is the basis of photosynthesis, the process by which plants convert sunlight into energy. Thanks to this phenomenon, life is sustained. Every time we eat a fruit or enjoy a green landscape, we must remember that it all begins with sunlight. This vital connection reminds us that we are part of a larger cycle, a cycle that unites all living beings in this small corner of the cosmos. Human culture has been profoundly influenced by light. From cave paintings to the great masterpieces of the Renaissance, light has been a constant inspiration for artists and thinkers. Isn't it fascinating to think that the same light that brightens our days has been the muse behind some of humanity's greatest works? Throughout history, light has symbolized both knowledge and hope, guiding us in our darkest moments. Today, technology has harnessed light in ways our ancestors could never have imagined. From instant communication through fiber optics to the complex images that allow us to explore space, light is the engine that drives our advancement. But what will the next steps in our relationship with light be? As we continue to innovate and explore, we are likely to discover new ways to use light that will change how we live. As we contemplate the future, we cannot forget that light is also a reminder of our vulnerability. Despite all our advancements, there is still much we do not understand about the universe. Phenomena like black holes and quasars show us that there are limits to our understanding, and that light can behave in ways that challenge our expectations. What other mysteries await us in the shadows of the cosmos? At the end of this journey through light and darkness, we have learned that light is not just a physical phenomenon, but a symbol of connection and knowledge. It invites us to explore, to question, and to dream. Light illuminates our path, both in the universe and in our own lives, reminding us that although darkness can be overwhelming at times, there is always a glimmer of hope and possibility. So the next time you look up at the starry sky, remember that each point of light is a story, a lesson, and a reminder that the universe is full of wonders waiting to be discovered. Light remains and will always be the thread that connects everything we know and what is yet to be explored.